Hi, so today I'd like to talk about how to turn fractions into decimals, all right? So in order to turn a fraction into a decimal, you need to look at the numerator and the denominator. So I put n here for numerator, that's always the number at the top part of the fraction, and the denominator, which is always the number in the bottom part of the fraction. So n for numerator, d for denominator. So I chose 2/5 as just a random fraction, and we're going to turn 2/5 into its decimal equivalent. So a way that I remember how to turn a fraction into a decimal is with our friend Dan. Like, who's Dan? I don't know. Well, I just made Dan up. So, and if your name happens to be Dan, this will be super easy to remember. So the denominator is always going into the numerator. So this is a long division symbol right here. And so the denominator is going to be on the outside of the division symbol, okay? And then the numerator is going to be on the inside of this division symbol, okay? So here's D and N, and so I figured an easy way to remember is to make our name Dan, all right? So Dan is going to help us out making 2/5 into its equivalent decimal. So let's try. Okay, so 5 is our D here, and remember D is on the outside. 2 is our numerator, so that goes on the inside. 5 does not go into 2. Ah, that's too bad. So if there's ever a situation in math that you run into a wall, then create another creative way to get out of that predicament. In this way, we can do this. Put a decimal point right here to the right of the 2, and then put a 0. So this is an important point. 2 is the same thing as 2.0. So we haven't changed the value at all, okay? So now, once you have the decimal point right here, put a decimal point right above it, okay? And now you divide 5 into not 2, because it goes in 0 times. 0 times 5 is 0. But now look, you bring down this 0. And I like to write a nice old arrow there. So I line everything up really nicely. 5 goes into 20 exactly 4 times. 4 times 5 is 20. Now, don't bring the decimal point down. The only time that you copy the decimal point is to put it right above, but it doesn't follow us down. 20 minus 20 is 0. Once you get to 0, you are done with the problem. And 0.4 is the decimal equivalent of 2/5. Now, the way that you say 0.4, 4 is in the tenths place, so you say this is 4/10. Okay? So I'm going to have you give it a try now with this next problem. Okay, so now we are going to move on from a fraction that has a decimal that stops. Do you see that once we got 20 minus 20 is 0, we just stopped? So it's not 0.46825, It's just 0.4. Stop. Nothing more than that. So we call this kind of decimal that ends. We call decimals that end terminating decimals. Terminating decimals. So this is a terminating. Terminate. So the word terminate is in terminating, okay? The word termin. Let's just look at the root termin. Think of a terminal, like a bus terminal, okay? A bus terminal is where the buses come in and then they stop their route. And then people can get on and off as they want, okay? So think of a bus terminal, which is a stopping point, okay? Well, that same root is in to terminate, or a terminating decimal, which means that those decimal places, they stop, okay? So that's a terminating decimal. Okay, so I'm going to give you some questions about what is a terminating decimal right now? Okay, so now we're going to do another kind of decimal. Sometimes when you have a fraction, the fraction, when it's turned into a decimal, it doesn't stop. It doesn't terminate. So there's another kind of decimal we're going to do. Let's say we turn 2/15 into a decimal. Okay, we're going to do it the same way. Remember Dan, our friend. We're going to keep our friend Dan. So 15 is now the denominator. And then 2 is our numerator. Okay, 15 doesn't go into 2 a whole number of times, so we're going to do our nice little trick here. And then we'll add, why don't we add 2 zeros, or let's do 3 zeros. Why not? You can add as many zeros after the decimal point. It doesn't change a thing. 15 goes into 2 no times. Okay, 0 times 15, 2, drop down, 0. 15 goes into 20 one time. 1 times 15 is 15. And subtract, you get 5. Bring down this 0. See, 15 goes into 50. This may take a little time, but I'll just tell you right now, it goes 3 times. 3 times 15 is 45. Oh, wait, I got another 5. Huh. Looks like I'm just going to keep getting 5s. And then I bring down the 0, so I'm going to get another 50. I'm going to keep getting 50, so I'm going to keep getting 3s, and it's going to go on forever. So it looks like the 1, there's only one of them, but the 3s go on forever. It's just going to keep going on. If you want to keep doing it to even be more sure that it really does go on for 3s forever, I'd spend like maybe 3 or 4 minutes, but after that, if it keeps getting to be a 3, I think it's safe to say that there's going to be a pattern of just 3s. So in order for us to be able to show the reader, like someone just coming up out of the blue and just looking at the board, right now, they would say, oh, this is a terminating decimal, but you and I know, and Dan knows, that this is not a terminating decimal. The 3 goes on forever. It keeps repeating. So how do we show that the 3 keeps repeating? There is called a decimal bar, okay? So a decimal bar is going to be placed above the digit or digits that repeat. So do you see that I put the decimal bar just over the 3? Because I only want 3 to keep repeating forever. I don't want the 1 to also be repeating. So if you do have a situation where you have more than one number in the decimal place repeating, then put the bar over both of them. But if there's only one in this case, so I want you to see that this is equivalent to this. Okay? See how just the 3 keeps going on? I'm going to need more space. In fact, I'm going to need an infinite number of decimal places to show how many 3s can be. Instead of doing that forever, because I got better things to do. I mean, I have television shows I like. So I want to watch those. I want to put a bar over the 3 and call it a day. What if, though, I accidentally put the bar over the 1 as well? That would mean something very different. That would mean that the 1, 3 keeps repeating. So that would look like 1, 3, 1, 3, 1, 3, 1, 3. And that would just keep going forever, okay? So 0.13 with a bar over it means something very different than if I just put the bar over the 3. Now, in some cases, you want to have the bar over the 1 and the 3, okay? How about, what if I came out with 4, 2, 5, and I wanted the 4, 2, 5 to keep repeating? So that would be 4, 2, 5, 4, 2, 5, 4, 2, 5, on forever. Okay, you see all of those. But if I just put it over the 2, 5, then that would be 0.4252525. So you see how a decimal bar, a repeating bar, really helps us out in order to tell exactly what kind of decimal a fraction turns into. So I'll give you a chance to do a little bit of that practice. I'll see ya.